Welcome back to Boiler Wild. My name is Eric Johnson. On this podcast, talk about boiler industry topics as well as personal development. Got a good one for you today. Hopefully you enjoy it. But first, thank you for all the people who have rated this podcast. I know more of you can rate it. So if out of the kindness of your heart, you can get on your podcast app right now and rate it 5 stars, that'd be great. It helps me and it helps others find this podcast. Let's get into it today. I'm going to talk about intermittent pilot flame failures and how to fix them. You may have experienced this, you may not. If you haven't experienced intermittent failures, you don't know the pain of having an intermittent issue. And I'm going to tell this podcast kind of from a service perspective, but if you're an in-house team or like a stationary engineer, you can still do the same troubleshooting perspective, but you will have a little bit more leniency because you'll be around the equipment all day and you can more so watch the equipment and be able to figure out what's going on rather than a service tech showing up and having to diagnose the issue right then and there, leaving, and then waiting for a call back to see if the problem goes away or not. So, picture this. Let's set the stage. Customer calls, hey, boiler 1 had 2 pilot flame failures last night, but it's running. Can you schedule somebody out here as soon as possible? Not a huge deal. It's running, but it'll fail 5 to 7 times a day is what our shift people are saying. And normally it starts with, oh, it failed once, oh, it failed twice, and people will just reset it. And it seems to work all shift. Oh, all right, it was probably a fluke. And then it'll start failing more and more and more and more. And then it may get to the point where the pilot doesn't light 9 times out of 10, and somebody just sits there, just keeps resetting it. And then finally it lights, and then, the boiler goes off to the races. But once the boiler cycles again, you're back into the same issue. But then the customer's calling and saying, hey, our boiler doesn't light. So now you go out there and you're a service technician going out there, and you always need to get a frame of reference for what the problem you're going to fix is. That is number one technician rule when you are going out there. And don't ever rely on the notes if you have like dispatching, because it ends up being telephone, and the person calling your dispatcher may not be the person that actually had eyes on the equipment. So say you have a maintenance person that is telling their supervisor what they think the problem is. So the maintenance person says, hey, this is the problem. I think this is what's going on, yada, yada, yada. And then that supervisor calls the dispatcher, and the dispatcher may or may not know much about boilers. They probably don't know much. They will have heard a lot of terminology, but they won't understand exactly what the supervisor is saying with good context. So then they'll write it up what they think the problem is. And then, so if you go off of that, you're now two people's interpretation away from the actual problem. But you should take that as a data point. Don't ever dismiss it as, wow, that's false, or I'm not going to read it. You just take it as a data point. You read it, you file it in your brain, and you go, all right, that is nice to know information, but I am not going to rely on that as the sole truth. So you get on site, you check in with your customer, and you say, I understand you're having issues. This is the issue with boiler 1. I'm here to solve that. And they'll probably say, oh, it's running right now, but man, it was giving us hell last night. So you're like, yeah, I'll see what I can come up with. And then you'll say like, hey, can I talk to one of the maintenance people that maybe was resetting it, and it was on day shift or something? And then you can go talk to them and say, hey, like, what have you guys been doing with this? And, you're just kind of going to talk to them and see what they know, what they don't know. They probably won't know a lot about the boiler. They may think they know a lot, but they will typically have misconstrued assumptions, and they've been normally rewarded for doing things. Like I've seen people say like, oh, you got to hold this reset button in for 10 seconds to reset the boiler. I'm like, no, that's actually not true. You just need to push it. But somebody taught them that you need to hold it in for 10 seconds, and that's what they believe the truth is. But you're not there to determine, if they're right or wrong. You're just there to collect data points. It doesn't matter if they're right or wrong. You're just collecting data. So you want to just interview them, say, hey, what have you been doing? Have you changed any parts? Have you done any maintenance? Have you had another service company in here? And you want to look around. You want to look for clues. Are there tools on the ground? Are there rags? Are there tools over in the corner of the room, like they just got done with a project and didn't wrap up all the way? Are there parts that have been changed that are over in the corner? Look in the trash bins. What is in the trash bins? Are there boiler parts in trash bins? Theoretically, there shouldn't be any boiler parts in a trash bin, especially when the trash is normally taken out and it kind of turns over. Any recent parts, it would either be from another service company or your service company, or it'd be the in-house maintenance team. So if you see parts in the trash bin, you are going to want to look for those parts on a boiler. And if they don't mention it, we didn't change any parts, they may know they didn't change any parts, or they may not know. They may lie to you. Some people will lie for different reasons. You're not there to call them out on their lie. You are just there to hear what they have to tell you, and then you go, all right, thank you for that information. And then you file it away in your brain and you say, that is good information, but I'm not going to rely on that as the sole truth. It is just one data point. So, if you saw parts in the bin, you're going to find those parts on the boiler and determine if, that was boiler 3. Oh, boiler 3 had this issue. That's what those parts were. Boiler 1 with this intermittent issue, that's not the parts. They didn't change anything. But then, look around. A lot of facilities will have dirty boiler rooms, and there'll be a little layer of dust and dirt on everything. What parts aren't dirty? That can indicate that they were changed recently. What parts, if you have piping, is there fresh tape? Is there fresh pipe dope? And you're going to want to look for anything where it doesn't look like the equipment has been sitting there. Anything that's disturbed and touched is what you're going to be looking for on the burner and on the boiler, and that can lead you to different clues. You'll also want to just look around you. We haven't picked up any tools at this point. You want to look around. Are they doing any capital projects? Do you see anyone else there? And this may seem like an obvious thing, but if you are looking around and you go outside the boiler room door and you see a gas company truck and some cones and people in a manhole across the street, that's a data point. And you say, hey, what is the gas company doing? And the maintenance people may say oh, they were here last week and that's when our problem started. Well, that's maybe a good clue to take that in. Or maybe they're building an addition and they had to extend the stacks. So you're walking around, you're like, well, that really wouldn't affect anything. But then you go outside and you're like, man, those stacks, they look different. And they say, oh yeah, we had to extend the stacks or whatever. We just added 20 feet to them. Well, that's going to really change your draft. And, if nobody ever rechecks the burner settings, I think 20 feet to your stack could change the draft and do all kinds of different stuff. Or if maybe they're cutting concrete, and the concrete dust is getting sucked into the boiler room, which gets sucked into the burners. You're just looking. You are observing. You are using your senses. You are using your eyes, your sight. You're using your ears to hear. Does anything seem abnormal in this boiler room? Does anything seem abnormal with this boiler that is having this issue? You're going to use your smell, obviously, and then touch. So you're just using your senses. We haven't picked up a tool yet. We are not jumping to conclusions. Intermittent issues, you want to always approach with a thinking mindset. This is also the same approach that I would use for every problem, but intermittent problems even more so. If you just load up the parts cannon and just say, oh, well, this is the problem, you change it, oh, that didn't fix it, then you change another part, oh, that didn't fix it, then you change another part, you are wasting your time, you are not a professional, and you are wasting your customers' money, and it's going to be pretty hard to explain how you just changed 8 parts and you basically rebuild a burner and a boiler, and you threw on a whole new gas train for whatever reason, and the problem isn't fixed. So I've seen that. That is not the answer. Don't pick up the tools right away. You need to observe. Walk around the boiler, observe, slow down. All right. What is the boiler doing? So then you're going to go into the alarm history. And a lot of people will say, oh, well, we left it locked out because they don't realize there's an alarm history. If you have a 7800, it saves the last 5 or so. It depends on the age of the 7800, but it saves the last 5 or so alarms. And if they're all the same, pilot flame failure, there's not really much more to look at. FireEye, kind of the same way. It can save the last, I believe 10, maybe 20. It all depends on what flame safeguard you have. It doesn't really matter whether it's parallel positioning or linkage. Whatever you have, you're just going to look at the alarm history, and if it's just a bunch of pilot flame failures, then that's basically all you need to know. But that will tell you roughly how often it's happening. And you also want to look, and this is a very, very small chance to see if the failures are happening consistently at a certain time. And this is only going to happen if you can see a date and time, which is only going to be with parallel positioning systems, and maybe like a PLC system, maybe, but a date and time when the failure happened, or you may be able to see that on BMS, but don't read too much into that. You just want to look to see, maybe the boiler was failing at midnight every single day, but like exactly at midnight, that would tell you something. All right, like what's happening at midnight? But that's like probably a very, very low percentage. You're just looking for patterns. You are observing. You are collecting data. You are filing information away in your brain. You are not jumping to conclusions. Troubleshooting takes time, and it takes slowing down, being patient, and having a method. And intermittent problems, you need to have a method. So I am going to go through this list. I'm going to do it off the top of my dome. So if I miss something, I'm sorry. Call me out. Let me know. And this list that I made it up for a typical power burner boiler. Very, very popular, but a package burner, package boiler. If you have a high efficiency condensing boiler with a special system and special setup and everything, it's going to change a little bit. If you have an atmospheric boiler, it's going to change a little bit, but the basics stay the same, and you just need to understand at the core, at the fundamentals. I always talk about understanding the basics. What needs to happen all at the same time in order to reliably light pilot and then transfer over to main. So let's go through the list. First, you need to understand that intermittent pilot flame failures are typically not hey, this part is broken, I change part, boiler now runs perfect. It is typically a degradation of multiple factors slowly over time. Everything on the boiler is wearing slowly over time, especially on the burner. All the parts that get energized are slowly wearing. All the parts that are moving are slowly wearing, and you need to understand that. So you need to expand your mind of beyond I need to find the problem. And then if I find a problem, that must be the problem. And then I light the boiler again. And if it lights, yep, we're good to go, fixed, and I'm out the door. If you do that, you will probably have a callback and you'll look dumb to your customer. You need to familiarize yourself with the equipment manual, see if there's any specific instructions on how to fix pilot issues and what the manufacturer recommends. You also need to find the pilot gas pressure and igniter setup measurements and any other measurements for the burner. This is going to change based on the burner and or package boiler package, but you need to have the manual. Don't rely on your memory if you don't have the manual. Your memory can fail you, and you shouldn't be memorizing measurements. You may be able to think, I know that measurement because I've used it a lot, but don't ever rely on it. You know what? You know how many times I've opened a manual thinking I knew a measurement and I was incorrect on the measurement, where I thought something had to be one way and I was incorrect. So never rely on your memory. Always have the manual. And if you are working on a piece of equipment and you haven't opened the manual or you don't have access to the manual, you are doing something wrong. You are never too good to look at the manual. Remember, you are there to fix a problem, not prove that you are a superhero service technician that just remembers everything and is too good to look at reference materials that is available on their phone. So I was going into it before, but if you did find any new pieces or parts on the boiler, you want to note those and you want to look into those first. You always want to start with the highest level things first and then work your way down into the lowest probability items. If you do that, you typically will find the issue, but you want to work through as many issues as you can and check everything. The mindset I come with to intermittent problems is if you touch everything that affects what you're working with. So in this case, we are working with an intermittent pilot flame failure. If you touch everything that is going to affect a pilot and a stable pilot, the more likely you are to fix the intermittent flame failure. You may not find anything that is wrong, but you may find, I'm a little gap out the igniter. I found a little this here, adjust that, I adjust the settings of this, adjust that, found this, and that may fix the problem. Next, do you even have pilot gas pressure going to the pilot? You want to make sure that you have this. You want to make sure that it is repeatable. Like I said, you want to check the big things first. I have seen people check and pull their hair out over intermittent pilot flame failures, and they didn't have proper gas pressure going to the pilot, and or they had just complete pilot flame failure because the pilot gas valve the manual gas valve was turned off after a maintenance or after like lockout tagout, and it never got opened back up and they didn't see it. But on an intermittent failure, we are assuming that we are getting gas pressure to the pilot and that the pilot is lighting a relatively large amount of times. But don't always assume that you're going to get gas pressure. You're going to look on the pilot gas line and see, hey, is there anything that looks like it's been touched that would affect the gas actually getting to the igniter assembly inside the burner so that the pilot can actually light. So the number one probably issue outside of just gas is probably air damper. It's either air damper or igniter, but air dampers wear out. So the next one is air damper. So on some more economical style burners, the bushings can be a bronze bushing and they can wear out and then wear through steel. So as damper bushings worn or the blades have excess play, the the blades on the air damper assembly they will have a little play just from manufacturing tolerances, but you should easily be able to see if the blades are moving more than they actually should. And then, like, are the damper blades dirty? They should always be clean. The edges of the blades will get dirt on them. And if there is a screen over the air intake, you want to make sure that that is clean. And then, have any of the position settings been changed recently? This is going to be more of a question that you need to ask the maintenance person, or you need to look in your notes if you have service history for your company. But has anybody been messing with it? If somebody has been messing with the settings of the air damper on pilot, you're going to want to note that, and you're going to assume that the settings are wrong. So on linkage burners, this is a little bit more difficult. You can look at the linkage and kind of tell shiny spots or maybe some marks that have moved, but don't always rely on marks, because in my experience, most times linkage burners and all the linkage will have 10 marks on it, and you don't know which one was actually correct. But you just want to observe and see, hey, is there anything moving on it? And on linkage burners, you want to make sure that all the linkage connections are tight and that the entire linkage system is tight. So you want to check all that. You want to put your hand on it. You want to stress test it. You're going to want to push and pull on each arm and connection, and then you're going to check the tightness of it. Don't be shocked, though, when one of the connections moves and you're like, oh, man, that must be it. You need to redo that connection. You need to make sure that the pilot light's off. You need to make sure that combustion is good, but don't assume that that is the problem. That could have just been another problem that you found while you were there and hasn't shown its head yet, and that linkage just hasn't been able to move and screw up your combustion and set the boiler or something. So don't assume just because you find something that, yep, it's good to go, pack it up, time to go. On linkage-less systems, everything's a little bit more repeatable and there's a little less moving parts, but you want to make sure that the air damper is still repeatable. You want to look at any connections, any couplers. Sometimes couplers have rubber wear parts or flex assemblies. Anything that's going to cause more damper play that is going to slowly wear out over time is going to need to be changed. You want that air damper to be repeatable on pilot, especially on smaller burners, and I'm talking less than 2 million BTUs. On, that's kind of what I call small. On less than 2 million BTUs burners, the air damper is so small that each position of the air damper opening adds so much air to the burner that the air damper becomes more critical on position on pilot and low fire. And typically, pilot and low fire are going to be the same position. On light off on a normal gun style burner, if you have a mesh style burner, this will change a little bit. You may light off at like 30 to 40%. Everything's different. You got to know what your burner is, what your package boiler is, and this is, once again, just general list. You need to cycle the burner a couple times and watch the damper move. Is the damper pilot position repeatable? Does the damper move slowly? If it's linkage, does the linkage move slowly? And does it move smooth, or does it like jump and like hang up and then jump? Or maybe the linkage binds up. And you also at this time want to take the linkage off the motor connection, and you want to move the linkage yourself by hand. Is the linkage hard to move? And this is especially with air dampers. You can have air dampers get hang up, and a really common one is the Cleaver-Brooks integral burner. If you don't know what that is, probably the most common or popular, well-known boiler burner setup. It's where the burner is integral to the front door of a Cleaver Brooks boiler. It's a very flat burner, but the bronze bushing can get grease and dirt on it, and it has a lot of surface area for the damper that spins open. And if the damper is a rotary damper and only moves like 45 degrees, but that bronze bushing goes against the shaft, and you should be able to flick it open and close with your finger. If it takes if it takes more effort than that, the damper is putting excess pressure on the linkage system and or linkageless. Maybe the actuator isn't powerful enough, and you need to rebuild the damper. I've done it before. I've had that fixed before where I had intermittent issues with the boiler. I could move it by hand, but it was very difficult. And you got to remember, with linkage burners, you're going to have power loss at every connection. So while you can move the air damper by hand and there's like some resistance, think about all the transmission loss through all those connections and then over to the motor. And you lose efficiency. So any effort that you have to put into moving the damper, that is going to be multiplied by the time the linkage system gets to the motor. Once again, on that Cleaver Brooks integral burner, you should be able to flip the damper open by your finger. It should just click open all the way up and then click open all the way down. And really that should be on any burner. There should never be significant resistance on an air damper. That will obviously change as the burner gets bigger, but I'm going to assume you're going to have some idea of what is the normal amount of resistance for how much mass you are moving. But if you have any hang up or tons of resistance on an air damper, you are probably going to have repeatability issues. I've also seen another style of air damper that's more of a wagon wheel on a burner. It's 3 plates stacked up, and those plates move, and they've got like triangles cut in them, and a little bit of dirt will get between the 3 plates and the linkageless. This was a linkageless burner, and the actuator would start having pilot positioning issues, and sometimes it wouldn't get to pilot position. And it wasn't that the actuator was failing or that there's anything wrong, but the resistance on the air damper would build up over time. And at about 14 months, the resistance would be high enough that it would start causing intermittent issues. It ended up being just built into the annual maintenance that the damper would get taken apart, completely cleaned and rebuilt, and then put back together, and then it would work for the next year. But if you didn't do it, 14 to 16 months, it would start having intermittent issues. Going back to worn bushings, this is a big one for smaller linkage burners, especially ones that are oversized and cycle a ton. You need to have repeatable damper positions. You want to look at those bushings. If they are ovaled out, the airflow can suck that damper to be in different positions, and that is why you want to look at the damper position when the motor is actually moving the damper, and you want to cycle the burner multiple times and see if the damper is repeatable. Another story, I was going to a hospital. It was late at night. This hot water boiler, there were 2 boilers. The boilers were oversized. It was all messed up, but they would cycle a ton, and one of them was constantly locking out. And the other one was having issues as well, but they're like, hey, we really need to have both boilers. And I'm like, all right. And, I'm in this penthouse. It's hard to get to. It's locked by like elevator access, just not an easy situation. and these burners have been there for a while, and they cycle a ton, and they're constantly moving open, close, open, close, open, close. And I was looking at the air damper box assembly, and the bushings had worn out of the damper. In this case, the damper was just a single blade, and this was a linkage burner, and the damper had worn the bushing away and had worn an oval into the actual metal of the burner on the damper box. So sometimes the damper would fall into the correct position and it would light the pilot, and then other times it would get sucked up and move the damper rod that goes through the two sides of the sheet metal housing. It would move the rod, and that rod would then throw the damper position off, and the burner would have too much air and it would go into pilot flame failure. Very, very frustrating, and I'll tell you how I fixed it. This is probably my most proud fix, and let me tell you, I felt kind of amazing after it. It's midnight or whatever at this hospital. We really need this boiler, and I don't have any parts. And how this is set up, you can't really screw in any supports to this housing because the damper would hit it on the backside. So if you have any through holes, the damper is going to hit it. I guess you could have welded maybe a washer on the outside. That probably would have worked, but obviously didn't have a welder, and that would take a lot of time. And I ended up, on this style of burner, the air damper was driven by the mod motor on one side, and then the rod would obviously go through the air damper box. You'd have the blade for the air damper, and then on the other side of the end of the box, the rod would keep going. It had a pretty large stick out, probably 12 inches, and then it would have the arm for the gas butterfly valve. Well, that arm would obviously move a ton because the support for the bushing on the side of the air damper box was ovaled out. So I needed to figure out how to support that arm. So what I ended up doing, I'm looking around this penthouse for just basically anything. And I find a block of wood, and I find a 1/2-inch pipe nipple, and I end up drilling a hole in the block of wood, making a hole, pounding the pipe nipple into the hole in the block of wood, and I've measured it so that I can get the block of wood in the right position for where the rod of the air damper needs to be. And then I find some zip ties somehow in like this back corner cabinet, and I zip tie this block of wood to the gas line that's coming up into the bottom of the burner. And once I do that, now the block of wood is zip tied to the gas line, and I have a 1/2-inch nipple that is pounded into this block of wood that is in the proper position for where the rod for the air damper needs to be. And then I put the rod into the 1/2-inch nipple and supported the rod so that the air damper position was repeatable, and that also at the same time the gas butterfly valve position was repeatable. And that temporary fix ended up being temporary for 4 months and worked. So that just goes to show that if you're creative enough, you can make fixes. I'll have to post that picture sometime on that fix. I was pretty proud of it. That's probably one of the best fixes I've had for boilers in a tight situation. I could have walked away and said, nope, nothing I can do, but it was really critical that this boiler ran. And once again, midnight, and I don't want to be there all night. I could have gotten a welder and welded washers, or I could have just told them, no, it's not going to run. It's broke. Sorry, nothing I can do. But sat down, looked at it and said, what is the goal? Support the damper, and I need a repeatable position. So I ended up figuring it out. So maybe I'll post that picture sometime. Moving on. Combustion air fan wheel. Is it dirty? You need to check if it's dirty. If a combustion air fan wheel is dirty, it's going to move less air. It'll change the airflow. It is unlikely that will cause pilot flame failure issues, but you are just looking at everything. So you want to see if it's dirty. Certain styles of combustion fan wheels, there's different styles like forward curve, backward curve. Certain styles will collect dirt more than others, so just be aware of that. And then second, is it rotating in the correct direction? You may think that this is dumb to check on a boiler that's been installed for 15 years, but you need to check it because the maintenance people may have rebuilt the motor and they didn't tell you or forgot to tell you that they threw a new motor on the burner, or they may have had it balanced and they removed the motor for testing or whatever, and they undid the wires and then they didn't put the wires back correctly. They may tell you, they may not tell you, but you need to check. You also may have an issue where power to the building gets reversed. That would reverse all the power, but maybe they had new 3-phase feeds ran in their boiler room and they mixed up the feed for the one boiler. Anything's possible. And that's why when you first start, you would be looking around and you would see brand new conduit and brand new electrical boxes. And you would say, oh, all right, we just had some new electrical put in. But then maintenance would say, oh, that's just, that's been in. That's not the issue. It's like, okay, well, I know 3-phase, you can change one leg and run a motor backwards. So how do I know that they got all of the legs in the correct phase rotation correctly? It's something you need to check. Very, very low percentage of when that's going to happen. But if it does happen to you and you find it, you will be snickering to yourself because you'll be like, no way, like, how does this even happen? But it'll make sense when you start asking, because when you say, hey, I found that the motor was moving backwards or whatever, they'll say, oh, we had so-and-so company in and they unhooked the 3-phase and then they hooked it all up again. We tested it and everything seemed good. So we didn't think that was the issue. So it's possible. Gas supply. Is the gas supply pressure to the inlet of the boiler correct per the manufacturer's directions? So you need to look at the manufacturer's data plate. Typically it's on the data plate, maybe in the manual for the size boiler you have. And you need to actually measure with a manometer the supply gas pressure to the inlet of the boiler. And you need to see if it fluctuates. If it fluctuates a ton, that may be an issue, because if the customer has 6 boilers and 4 water heaters, maybe it's a hotel, and when all the water heaters come on in the morning when everybody's taking showers and all the boilers are still running hard because it's a cool morning, they're running out of gas and they have a gas issue or something like that. So is the gas dynamically stable? So is it dropping more than 20% when all the equipment is off versus when equipment is on? You may not be able to check that, but you want to make sure that you are having the proper pressure and also that it is not fluctuating a lot. And by a lot, I would say more than 3 to 5 inches, but that's going to depend. If your inlet gas pressure is 2 psi, 3 inches isn't much. But if your inlet gas pressure is 8 inches, 3 inches is a lot. So that's something to keep in mind. And then, is the regulated pilot gas pressure correct? So you're going to have supply gas pressure. You always want to make sure that upstream is correct. And then, is your regulated pilot gas pressure correct? So on a typical burner, you're going to have a regulated pilot gas line, and then you're going to have a regulated main gas line. So you're going to have a little pilot regulator. You want to make sure it's correct. Typically, the number is 3.5 inches. That is a general number. That is not the number. Don't rely on rules of thumb when you are looking at regulated gas pressure. And then if there's a vent line on the regulator, is the vent clear? So you want to check if the vent is clear. Sometimes this is hard to do. What I like to do is take the vent off and see if the pilot flame changes or acts differently, because that will indicate if the vent is blocked. You can go outside, find the end of the vent, look for bugs and maybe wasp nests. A blocked vent will cause pressure control issues with your pilot gas regulator, and it will build up pressure and cause back pressure on the top of the diaphragm of the regulator, and that will cause intermittent problems. Don't leave the vent line unhooked. If there's a vent line, you don't want to leave them unhooked. You want to use them. I know it's a very low percentage and really doesn't make a difference to much people, but it is codes in most places and needed to have a vent line. But you can, the best way if you have a really big vent line is to take an air gun with some compressed air and blow compressed air into it. If it builds up pressure, you know it's plugged. If it's a really small copper line, you may end up having to replace it. If it's a larger 1/2 inch line, typically is not going to get plugged except at the very, very end where it's on the outside of the building, and that's where bugs like to get in and build nests. Draft control. Is there a draft damper on the boiler? Is the draft damper, is it manual? Is it automatic? If it's a manual damper, is it locked into position? Does it look like it's been moved? If the stacks have added 20 feet to the height of the stack, that will change your draft. So keep that in mind. Maybe somebody moved the damper. What is your draft when the burner and boiler is off? You can check that. If your draft is excessive, that may be an indicator that you may need a draft damper. But at the same time, you want to make sure that you are under the assumption that the boiler was working correctly at one point. Don't say, hey, you have excessive drafts, you need to add an automatic draft system control. That's the fix, because that's probably not the fix. It probably should be added if you were going to make the most correct boiler and setup, but it's not the fix in this issue and not appropriate for this issue. So then if there is an automatic damper, has it been jumped out? Is it just locked open and the switch is jumped out? If the automatic damper isn't working, that is an indicator. Sometimes it may have just been jumped out for 10 years. Sometimes that may be the issue. But once again, we are looking at everything. And then obviously you want to make sure the condition of the stack is the same. You want to make sure they haven't been lengthened or anything like that. Very, very low percentage, but once again, you want to be checking everything. Pilot gas valve. Is the valve getting the correct voltage? Is the valve opening when it gets voltage? Are you getting gas pressure on the downstream side of the valve? And you want to make sure that you trace all the wiring that goes to the valve and make sure all the connections are tight and that all the wiring is in good condition. All the way from the flame safeguard all the way to the valve. Yes, I know that may take a little bit of time, but it is worth it. You want to check all the connections. Sometimes, and this is typically most times actually, you'll find a 4x4 box on the side of a boiler. You'll open it up and there'll be a ton of wire nuts in it. And that is connecting the boiler wiring that is on the boiler to the burner wiring that is in the burner. And everything isn't just one wire that is ran end to end. And you have wiring nuts. Those wire nuts, they may have water in them. They may get loose. There's all kinds of different things. And a loose wire nut can easily cause an intermittent voltage delivery issue to the pilot valve. So check it. Don't assume anything is correct till you have verified it's correct. And then if it's a solenoid valve, you obviously want to look, is the solenoid clicking open? Is the solenoid head buzzing? Does there seem to be an issue with the valve at all? I've heard previous podcasts, a person was telling a story about a pilot issue on a valve where the diaphragm was actually sticking. So when they would reset the boiler multiple times consecutively, the pilot valve would stick, but under normal operation, the pilot valve would free itself during the normal operation, so it wasn't failing. But when they were resetting the boiler during training, it would stick. So you're going to want to look at stuff like that. But once again, don't load up the parts cannon and change the pilot valve because you think it's bad. Unless you find a definitive issue with the valve, now is not the time to change the part. And changing the part with hopes and dreams is not the correct thing to do. Is the ignition phase starting when the air damper is in the proper position? So when you have a linkage burner, you will typically have a motor like a methodical 4 motor, or you'll have the Siemens equivalent. And there are cam settings inside the motors that will tell the flame safeguard when to start the ignition phase of the burner. With the methodical 4 motor, if you don't make that cam in the correct position, then the flame safeguard will start ignition when the pilot damper is too far open. You're going to go into purge. It's going to go into high fire air damper position, which is all the way open. And then it's going to go through the purge, pre-purge, and then it's going to come down and be traveling to the ignition position, which is typically low fire. And as it's coming down, if it's only 50% of the way down and it starts the ignition phase, you're going to have way too much air. And the pilot may light right at the end of that ignition phase because the air damper is going to keep traveling down in that scenario, but it will cause intermittent pilot issues. You want to make sure that you have the cam set correctly to where your module 4 motor, whatever your modulation motor for your linkage settings, you want to make sure that it starts the ignition phase and that the linkage is moving for about 1 second after the ignition phase starts. So if you're looking at your motor and you will hear the click of the pilot valve and you'll hear the igniter go, you should see that motor arm, the linkage, moving just a little bit more than after that click. If it stops moving right at that click, sometimes I've seen where the cam is set so close that it doesn't depress the cam switch all the way, and you'll have an intermittent issue. But that will typically lead to the boiler just not even reaching ignition position, but it will lead to an intermittent issue that will seem like an intermittent pilot issue. So you want to make sure that that is set correctly. On linkage lists, this is typically not an issue. If you have position issues, you're going to get air damper, actuator position errors. That's typically how that shows up. You're not going to have like a generic pilot flame failure on that issue. That's going to change based on your parallel positioning system, but that's also the magic of parallel positioning. It gives you more data so that you can troubleshoot problems more effectively. Then going to the igniter. So then, is the igniter gapped correctly per the manual? So you're going to open up the manual. Yes, I know how terrible and hard that seems. You're going to find where it shows the maintenance section or wherever the igniter setup is, and it's going to have measurements. Hey, the igniter should be this far gap away from this surface. You're going to make sure that you have the proper gap. You're going to make sure that the igniter tip is not worn out where the gap, so that the gap is larger than it needs to be. A worn out igniter tip will not cause the problem. If you look at it and say, oh, the igniter tip is worn, that's the problem. No, the igniter tip is just metal. There's no issue with worn metal. The only issue comes from when the worn metal gets to be so worn to where the igniter tip cannot be positioned correctly for the gap. So don't see a worn out igniter tip and be, oh, well, that's the problem. I need to change the igniter. Well, I don't have the igniter, and I'm just going to tell the customer they just need a new igniter. No, even if you have a worn tip, you can bend the igniter a little bit to get it into the proper gap. But it all depends if you have just a straight igniter or it's curved a little bit, or some of them have like a square on the end. It all depends on the style of the igniter, but you want to make sure that the tip is in halfway decent condition. And then, is the igniter sparking off the correct surface per the manual? This is a big one. Remember, don't rely on your memory. Always check the manual. You may be surprised. Story time, once again, called out for a very frustrating boiler that 2 contractors couldn't fix, and went out, and I was very familiar with the boiler, very familiar with maybe what would cause pilot issues. But once again, intermittent pilot issues, my method to fix it is touch everything and you'll probably find the issue. So take out the burner and checking the whole assembly, and I find that the igniter is gapping off the wrong surface on the end of the burner. It will work, but it is incorrect. It will spark before the gas, and it ends up being where the spark will form a carbon bridge, and it will either ground the igniter or the spark is behind the gas and it won't always light the gas as it comes out of the burner. So I cleaned everything up. I redid the positioning of the igniter. I re-gapped it, obviously, gapped it properly and fixed it. And that was a very frustrating event and series of days for the customer because nobody seemed to fix their boiler. But the only reason I fixed it correctly is, one, I was familiar with it, but even more is I took the time to open up the manual and understand what the igniter gap should be and where the igniter should be sparking. Just because the pilot lights doesn't mean that the igniter is sparking off the correct surface. Always go off what the manual says, unless in the very, very rare instance, you know better than the manufacturer. And that typically will come with a burner that maybe has a very unique design or parts that have been changed, that sometimes you found that you have to change the igniter position or have changed how it sparks, where it sparks. But that is going to be very rare. Never go off the rarity and say, well, this burner is different. Yours is probably not different. Go off the manual. Always reference the manual. Before you get crazy with gapping the igniter, you're going to want to take the igniter out and inspect all of the porcelain on it. And then you're going to want to look for any hairline cracks. It's helpful to clean the porcelain. Sometimes you're going to get dirt on the porcelain and it's going to be hard to look for cracks. And don't see scratches and think it's a crack. A crack should be visible. They will be very hairline, but you will also, it's also common to see maybe like a very pinhole black mark where the crack is, and that can be where the spark is coming out and sparking on the wrong surface, coming from the porcelain. So be very careful when you're looking for hairline cracks and little black spots to not miss them, but also don't think that dirt or imperfections in the surface of the porcelain is a crack. It should be very obvious if you were to actually hook up the igniter and set it all up. the voltage would come out of the porcelain and be sparking in the wrong spot, and you would be able to see that, test that if you are unsure if your porcelain is cracked or has a hole in it. And then you also want to check, does the igniter have continuity from end to end? This is a very low percentage problem fix, but you want to always check the basics. Sometimes the tips where the wire gets connected can be a very, very thin, and an igniter, if you don't know, is typically just a metal rod that has some electrical connection on one side, and then it's just a rod bent up on the other side, however it is. And I have never seen a rod break under the porcelain. That would be pretty obvious, but I have seen the electrical connection end. I have seen them very, very thin and or bent where it could be very weak. Is that going to cause an intermittent issue where the igniter can't get spark at the end? Probably not, but that may be another issue of, hey, we just need to replace this igniter. It looks like it's going to fall apart. Once again, you are looking for everything and you are checking everything. Ignition transformer. This is a big one. This is probably number 3 on the list of most likely for intermittent pilot flame failures. Don't assume because you see spark that spark is not the issue. So when you're looking at your ignition transformer, you need to be mindful of how many times the burner has cycled and how old the ignition transformer and or burner setup is. It is probably likely that the ignition transformer is original to the burner. Most ignition transformers have date codes on them, and now the date code can't be always when the ignition transformer was installed. It's when it is manufactured, but always assume probably 1 to 3 years within the date code. So, it's 2026 right now. If you see a date code and it says 2003, that ignition transformer has some miles on it. Don't automatically change it, but just be skeptical of a ignition transformer that is from 2003. It could get weak. If you look at the date code and it says 2022, it's probably fine. But once again, check it. Don't ever assume. So an ignition transformer typically doesn't just fail. I don't think I've ever seen one not produce a spark, but the spark will get weak. And there's 2 types of ignition transformers, and you really have to know a little bit about what kind of spark the ignition transformer is going to make. But on gas, typically the ignition transformer is going to be 6,000 volts. And how I like to describe it is, do you get a thick blue spark with orange in it? And I don't know how to describe it any more than that. And also you can kind of tell from looking at it of, does it look like it would hurt, and or can you hear it really buzzing when it's sparking? And that's a very vague description, and it's hard to describe what a good spark is, but a good spark will always have orange in it, and it should be able to easily gap a 1/4 inch gap. Typically, your igniter gap is not going to be 1/4 inch. It's going to be smaller than that, maybe 3/16, maybe 1/8, but it should easily be able to do a gap, and you should be able to extend that 1/4 inch gap. If you don't know already, once you have the spark going, you can extend the gap. But if you have like a 3/4 inch gap, the spark is probably not going to be able to arc that gap to start. But if you had a 1/4 inch gap and then extend it to 3/4, you may be able to keep the spark at 3/4. This takes a little bit of experience to look at, but I know from experience a weak spark is a very, very thin spark that is very blue, doesn't have a lot of orange in it, but the key thing is it is thin. So the electricity on the spark ends up being very thin versus a fatter spark that is blue with orange in it that is able to gap easily a 1/4 or more. A weak spark will struggle with a quarter. And you need to be mindful that if you check it, that you're like, oh, it makes the gap, it's fine. You need to have a little bit of discernment here, because if you're working with an intermittent pilot flame failure, it's making the gap probably 9 times out of 10. But you need to make that gap 10 times out of 10. So it's hard to describe, but if you find a very thin spark and the ignition transformer is old, it is probably worn out. But once again, don't just blindly change the ignition transformer and say, oh, the spark's weak, that must be it. If you actually know and say, hey, this spark is weak, I know that, all right, you can change it. But once again, we are always wanting to change parts for a reason. You never change parts because you have a feeling or you're guessing. Guessing is not troubleshooting. And then just the other part with that is make sure that the igniter assembly has a good path to ground. This one is not as common, but in order for spark to work, you have to have a ground path for the spark. So make sure that is good. Sometimes there will be a ground wire, sometimes there isn't. Just check it, check what's there, but you shouldn't have to make major modifications if you think something is wrong. Once again, we are assuming that this worked at some point correctly. Making major modifications to a burner or sanding off paint or adding a ground wire is probably not going to be the fix. Ignition wire, is it in good condition? So on gas, you're going to have 6,000 volts, or on oil, you'll typically have 10,000 volts. And an ignition wire is different going to be than your normal electrical wire. It's going to have a thicker insulation and a different rating than your typical electrical wire that you're going to wire up your boiler with. And you need to make sure that that rubber insulation doesn't have any cracks in it. And then it is very common for, if the ignition wire touches metal and like lays along metal, that a rub through or a crack from dry rotting will happen, and then it will spark to that metal instead of sparking at the end where it is connected to the igniter, so that the end of the igniter is not getting sparked. So pay close attention to any place that the wire ends up touching something. I typically prefer that the wire be suspended in air. So if you're going to have an ignition transformer and then you have the wire coming off the ignition transformer and it goes to the end of the igniter, you should always try to make that as close as possible to be suspended in air. That is not always possible with all burner styles. Sometimes it's got to go through a plate. You'll have a grommet. Always check anywhere that a plate or grommet will touch the wire. 6,000 volts is going to find its way through that insulation in a hole or a little crack. It will be very hard to see, but if you reset the burner a couple times and you watch it, you will find, especially if you turn off the lights in the boiler room, you will see if the spark is coming out of the wire in the incorrect position, because you'll see little blue lines coming out and you'll need to replace the wire. Don't put electrical tape on the wire. That's a hack if you have to, but that is not a real fix. You need to replace the entire wire. Ignition wire is relatively cheap. You should probably have some on your truck if you're a real burner person, but replace it. Wrapping it in electrical tape is a short-term fix, but as you know, if you're experienced, short-term fixes become permanent fixes. But that is not what we want to encourage, because if one part of the wire fails, another part's probably going to fail. And that's a relatively cheap part to replace, and calling somebody out for service and downtime is very expensive. And then check both ends of the connections. Are they tight? Are they actually screwed in? It's hard to describe, but I've seen electrical connections where it's a two-part connection and the end of the ignition wire actually was not touching the metal part of the connection. So the two-part connection came together, but it did not actually touch the wire. So it looked like everything was working correctly. The ignition transformer would come on, but I was not getting spark on the igniter. So most people would say, oh, I'm not getting spark on the igniter. The ignition transformer must be bad. Nope, you got to check the ends of the wire and make sure that you are having continuity from end to end and that your connections are correct. And obviously, you want to make sure that you don't have any corrosions or loose spots on the connections. And then the diffuser swirler of the burner. So this will obviously change based on the burner, but is the diffuser position correct? And this is a little bit more in-depth troubleshooting. I wouldn't start with this, but is it correct per the manual? And then is the pilot gas tube and igniter assembly positions correct per the diffuser? Check it. This is something that may slowly change over time or somebody incorrectly set up. It may move. Typically, diffusers will lock themselves in place just from dirt and corrosion. You may want to look at the diffuser, pop an inspection plate open on the burner, and if there's some shiny spots on the diffuser or like on the connections or whatever, you'll instantly know that somebody recently moved it. But you want to check it. That's a little bit more in depth on checking it. That is not where I would start. This list that we're going through is not in order, but there are higher level things I would start with. That is the air damper, that is the igniter, and the ignition transformer. They're more likely to cause an intermittent pilot issue versus a diffuser positioning that is slightly off of versus like the pilot tube, but it's possible. So reset the boiler and you're going to look at pilot flame signal strength. This will depend on your flame safeguard, but for example, the Honeywell, the max flame strength for a Honeywell 7800 is 5 volts DC. So hopefully you have a display. If not, you can also check it with a multimeter on the front of the Honeywell 7800. But if you have a UV or an IR, you should have 4.5 to 5 volts DC. If you have a flame rod, 2.5 to 3.5 is good for flame signal. On a flame rod, you are going to have a lower flame signal. And then if you have flame signal issues, that may be a sighting of the pilot tube or of the UV sensor or IR sensor of the burner. Sometimes those sensors can sit off the front of the burner and they may get bumped and bent, and now they're not seeing the correct sighting of the flame. That tube positioning, sometimes the tube can move in and out on the burner. You want to check that that tube is locked down in the correct position and that the end of the tube is not too far sticking past the end of the diffuser or too far behind the diffuser. Once again, this is going to be different per the burner manufacturer, but you're going to look in the manual and check it if you're unsure, or check it if the pilot tube seems loose and wasn't locked in and maybe there's marks or whatever that show that it's moved. I have had in the past, it was an older burner, but I've had an issue with pilot flame strength where main would see fine, but pilot, it had issues and it would intermittently lock out. And I ended up having to polish the inside of the pilot tube because the tube was so long that for some reason the tube had dulled and lightly corroded. I believe it was steel, but it had just lightly corroded to where the tube walls were a darkish gray, blackish color, and it was only seeing the very, very center of the tube. But when I had polished the inside of the pilot tube, the light from the pilot, the UV light for this UV sensor, had actually bounced down the tube better, and it was a night and day difference between polishing the inside of this long pilot tube versus not polishing it, and never had any pilot issues after that. So I was surprised on that one, and that was something I pulled my hair out over, trying to find that issue. But once again, never rule out an issue. You're touching everything. And then also on that, you want to make sure that the connections on your flame sensor are correct, and then also correct on all the connections. If the wires don't run directly to the flame safeguard, you want to make sure that those connections are tight. That will typically, if you have issues with that, that will typically come up as pilot and or main issues. If you don't have any main flame failures, you probably don't have a wiring connection issue on your flame sensor, because it wouldn't really matter if it was pilot or main. The issue would happen anytime that the boiler was running. But if you only have pilot flame failure issues, it's probably only going to be a sighting issue of the pilot. And then when you get to main, you'll probably have typically a good flame signal. And then, so if the pilot does light pretty repeatedly, you're going to look at how stable the pilot is. So most boilers you can observe from the rear and see the burner lighting. If you can observe it, you're going to look at how stable it is. If the pilot is really small and blue, it's probably has too much air. If it's really large and orange, that is probably correct. A good pilot, and this is going to change once again with the burner. There's no rule of thumb, but the pilot should be blue with orange tips. That's typically a good flame, and this is on natural gas. That's typically a good flame. If it's very blue and small and dancing all over the place, or even goes out and then comes back, that is going to be a stability issue and probably too much air. So you're going to be looking at your air damper positioning. And then obviously make sure that the pilot is actually coming in the right spot. Sometimes the tube on the pilot tube can move, and the pilot can light in the wrong spot. So whether it's lighting in front of the diffuser, after, or behind the diffuser, or like one side of the, like, you want to make sure everything in the drawing of the burner manual is correct, but just make sure your pilot is lighting in the correct spot and that your sighting is actually sighting and seeing the pilot. If low fire lights off in the same position as pilot, what is your combustion like on low fire? You want to check that. So if the boiler is lighting pretty consistently, check the combustion on low fire. Does the combustion look fine? You are just looking for fine. It doesn't have to be perfect. The combustion on low fire is not going to typically affect your pilot, but what you were looking for is way off. So is the combustion really rich or really lean? Really lean on low fire would indicate that I have way too much air on pilot, because the low fire and pilot positions are typically on most burners the same. If they aren't the same, this doesn't apply. But if it lights low fire at the same position as pilot, and low fire is really, really lean and the combustion is off, look at your air damper if you haven't already, and check your air damper settings. And if it's a linkage burner, obviously check all that. I've already went through all that. But you are just looking for indicators of where to go. Don't make any changes to low fire if it's 1 or 2% off from where it should be at this point. That is not what you're there for, and that is not going to be the fix. If it's really wrong, you need to make changes, but really wrong should be, why are these changes affecting the pilot? The problem will be showing up in low fire as well, but main flame is pretty resilient to light under abnormal conditions. Pilot has to be pretty perfect for the conditions to line up, just because it is a little bit more delicate phase of the burner combustion process. And then you want to check the manual again at this point for any specific characteristics of the burner that you're working on that may cause an issue. Always check the troubleshooting parts of burners manuals or packaged boiler manuals. Sometimes they have some good troubleshooting tips, sometimes they don't, and they're really general, but you want to check those, and you want to educate yourself and look in the pilot section, setup section, anything that's going to be unique to your burner. Once again, on the Cleaver Brooks Integral style burners, the little air port for the pilot, there's a plug that you can't see unless you're laying on the floor, but it is on the bottom of the burner. You take out the plug with, I believe it's a 1/2-inch square, and you take out the plug, and there's a little orifice hole in there. And if that orifice hole gets plugged up, you will have intermittent pilot issues. Ask me how I know. So that is the list that I came up with. Hopefully that helps you. Always remember, don't make changes, just make them without knowing what you're doing or why you are making those changes. You want to observe all the data first and then work through the obvious large problems and then work to the not so obvious ones. So if you have intermittent pilot flame issues, you are not going to just pull apart the burner and check the diffuser placement. That is probably not what I would start with. That is something that I would work down the list that I previously talked about and look at air damper positioning and igniter and the voltage and everything and gas pressure. That's all bigger stuff that's more likely versus the smaller stuff. Remember, don't go hunting for zebras in the jungle. It may seem like this huge mystery of this intermittent issue that you can't solve. Trust me, it is solvable. The boiler ran correctly at one point. You just need to find the issue, and you need to touch everything that affects the pilot lighting correctly and stable on the boiler. The more things you touch and the more things you calibrate back to factory settings and or settings that work, the more likely that you mix the perfect combination of getting the pilot stable again. If it is a newer boiler and the pilot has never been stable, that may be a different issue, but you still need to work through everything. But the fix may not be a smaller fix like that. It may be, hey, we have too much draft and we need a draft damper, or we need a barometric damper on the stack, or something like that. You also want to remember that it's likely that this issue was caused and developed over time, and at one point the boiler ran correctly. So once again, everything wears evenly on the burner and boiler, and it's not like one part breaks and then everything else is perfect. Everything just wears a little bit slowly over time. So everything may get a little bit off, and you want to put it all back to zero and say, hey, this is worn, we're going to replace that, we're going to replace this. Checking the pilot gas pressure, that's correct. Nobody's changed that. Checking the igniter gap, hey, that was a little bit off, I adjusted that, I checked this, I checked that. You want to be looking at everything. Going and just changing everything without knowing what you're doing will probably lead you further from the issue. If you are adjusting your low fire settings because you think your low fire is the reason for your pilot, or you're just loading up the parts cannon, that is probably not going to fix your issue. Always assume that the boiler was correct at one time and that there's probably 1 to 4 small issues that, when combined, those issues lead up to an intermittent pilot flame failure. Always reference the manual. Don't rely on your memory. I can't tell you how many times I thought I knew something, checked the manual, and been like, oh, I was wrong. All right, I misremembered. I know the basics. I'm not going to memorize measurements that are specific to specific burners and manufacturers. I have also reread manuals on a job where I haven't seen a burner in a while, and reread and skimmed the burner section for like a pilot light off, and there's maybe a note or something, and it says, hey, make sure this is really important. And I go, oh, I should check that. That's a really good idea. And then I check it. Like, always be reading the manual. The resources are there for you. Also, don't be the person that calls technical support and says, hey, I have a intermittent pilot flame issue, and you haven't even opened the manual. Help yourself first before you start dragging other people into your problems. And then the most frustrating part for me is don't walk away and say, well, the boiler lit for me, call me back when it fails again. That is unacceptable. If you didn't touch everything and check everything and go through the whole system, the problem is probably not going to magically disappear, and the customer is only going to get more frustrated. And if you are a service technician, how is your company going to bill for your time for you to show up and tell the customer, oh, well, I reset it 20 times and the boiler ran, so there must not be an issue. Call me back when there's an issue. Let's play this out. Okay, so then the boiler reset and ran each cycle for 20 times. And you tell the customer, oh, well, I see the pilot flame failures, and I know you said it failed last night and the night before that and the day before that and the day before that, but it's not failing for me, so call me back when it fails again. So the customer will call your office the next day and say, hey, the boiler failed last night, and we left it on the failure. We didn't change it. Okay, well, you show up. Well, you already knew that it was a pilot flame failure, so that's not new. The diagnostic history, it's probably pretty limited if it's just like a 7800, but even if it is a parallel positioning system, that's already information you could have looked up and stored. There's nothing that will be new information that will tell you something new from having the boiler in failure and not reset if you have the ability to just look at error codes and error code history. There's nothing new that it's going to be able to tell you. Walking away and saying, oh, well, the boiler worked for me 20 times, call me back when the issue arises again, is lazy, and you're not trying to solve the issue. You are looking for a broken part. You are not looking for all the wear or all the components that are just slightly off to where the variables mixed together makes for an intermittent pilot issue. That is unacceptable, and the fix and the proper way to go about it, once again, I've repeated this multiple times, is touch everything. If you don't know what to touch everything. Go through all of the burner. Go through all of the gas lines, the pilot valve, the regulator, the vents, the igniter, the ignition transformer, your draft, your settings, your combustion air fan, the settings of the diffuser, your positioning, your pilot signal, your wiring. Go through everything. The more you touch, the more likely you are going to accidentally come across the problem, and you may fix the problem without knowing it. You may get to the end of the day and say, I don't know if I fixed the problem, but I found this was a little off, and that was a little off, and this was a little off, and I adjusted that, and I did this, and you write it up and say, hey, this is what I did, and then it may fix the problem, but that is a more likely fix versus, I don't know, the boiler ran 20 times for me, call me back when it fails again. Because if it's failed every day for the last week, I can guarantee you it's going to fail again, and calling you back is going to be no new information and is a waste of time for your customer, leads to more frustration, and it's a waste of time for your company, because how do you charge for that? And then, last point, avoid the parts cannon. If you are loading the parts cannon and just blindly changing parts without knowing and actually diagnosing why a part is bad or how it's partly failed, you are just guessing. Guessing is not troubleshooting, and guessing is for hacks. Listeners of the Boiler Wild podcast are not hacks. You are to troubleshoot the boiler properly, and you are to lead your customer in the correct way that they say, wow, I really hired a boiler expert. They know what they're doing. Changing all the parts on the burner is not troubleshooting and not a good solid foundation of, wow, I hired a boiler expert. Anybody can change all the parts on a burner and get lucky. I'm not paying $200 an hour for somebody to change all the parts and bill me $4,000 for parts and over a week of callbacks of randomly just changing parts. Troubleshoot, don't guess, and come to logical conclusions and read the manual. Thank you for listening to this. If you found it valuable or I missed anything, if you want to add anything, you can DM me on LinkedIn or email me, eric.johnson@boilerin.com. I appreciate you for listening and stay wild.